we need to prove cos theta over 1 minus sine theta is equal to secant theta plus tan theta. Now, in proving any trigonometric identity, there are few fundamental identities that we should already know. And here are the general guidelines, I would say. Whenever you try to prove a trig identity, then change all the trig functions to sines and cosines. So if you see cosecant, secant, tan, or cot, write them in terms of sines and cosines. And then you got to know at least this Pythagorean identity, cos square plus sine square equals 1. If you know the other two Pythagorean identities, that's even better, but this is the minimum we need. And then there is difference of squares formula from algebra we want to recall. A minus b times a plus b equals a square minus b square. This gets used up quite a lot. And finally, to combine two fractions, like if you have to add two fractions, a over b plus c over d, the fastest way is to cross multiply and get the numerator, ad plus bc. And then to get the denominator, you simply multiply the denominators. So these are some of the fundamental steps we need to take. So if I have to prove this is equal to secant theta plus tan theta, notice the right side I can manipulate. So let me start the proof by rewriting the right side. Right side of the equation is secant theta plus tan theta, and I would like to convert both of them to sines and cosines. Secant is 1 over cosine and tan is sine over cosine. Now, if I have to add these two fractions, if they have the same denominator, then I don't have to cross multiply. I can take the common denominator. In that case, taking the common denominator is so much nicer because your numerator will just be 1 plus sine theta. Now, is that what I have on the left? Actually, no. So from here, I need to arrive here. So what I'm going to do is so it looks like I need a 1 minus sine theta in the denominator. So I have 1 plus sine theta over cos theta. What if I multiply and divide by 1 minus sine theta? So it's going to be, now you can multiply and divide by anything you want. Now notice what happens on the numerator. It's going to be 1 plus sine theta times 1 minus sine theta. Now that's where we know if you have a plus b times a minus b, then it's simply a square minus b square. So a square, 1 square is just 1. And when you square sine theta, you get sine square theta. And look at the denominator. We don't want to multiply this yet because then it will destroy the 1 minus sine theta, which I wanted to have in the denominator because the left side has that. Now, what can we say about 1 minus sine square theta? Well, that's just cos square theta because sine square plus cos square is 1. So 1 minus sine square would be cos square theta divided by cos theta times of 1 minus sine theta. Now it looks like we are getting there. You see there are two copies of cos theta in the numerator and one copy of cos theta in the denominator. So I can get rid of one of the copies. So instead of cos square, now I will just have cos theta over 1 minus sine theta, which is what I have on the left side. So we proved.